Well, welcome back to RD Works Learning Lab. We left off last time having just successfully tested my new baby. It's in, it's working, and it's powerful. Now all we've got to do is to set the beam up so that it gets through to the work. I've tried several methods of setting the beam up in the past, and every time I do it I find something new. So I decided I would sit down this time and think about it completely logically. What I've done, hopefully this time, has organised a complete logical set of steps that you should go through to set your machine up. Now, the first thing you must do is mistrust the machine. Let me explain. I want you to imagine yourself as a laser beam travelling down that tube and getting to that first mirror. Now, although the mirror starts off life as a 25mm disc, by the time you tip it through 45 degrees, look what happens to it. It's turned into an oval. Now, that's what this picture is showing you. What we've got here is a picture of the mirror as the laser beam sees it, and this is the laser beam itself. Now, the laser beam is only 6mm diameter, but by the time the mirror is tipped over, okay, although it's still 20mm tall as opposed to 25mm tall, because it's just encased in a little enclosure there, in the other direction we might have as much as 12mm. It might be 11mm, but it's in that sort of region, 11 or 12mm. Now what that means is that we've got a very narrow target to aim at. For a long time, for some stupid reason, I thought I'd got quite a large target to aim at, and it wasn't until I thought about it, which I should have done before, that I realised that it was quite a narrow target that we're aiming at, and we've got to be pretty accurate with our laser beam and our mirror alignments. So if we've got a 6mm beam and a 12mm wide mirror, we've got 3mm each side maximum. So I can only really sensibly afford to have my beam 2mm off centre to play safe. So I want you to keep that fact in mind. We've got to get the beam within 2mm of the centre of the mirror all the way through the system. So here we've got the laser tube with the laser beam coming out of it, hitting mirror number 1. Now ideally it should run along here absolutely parallel with this y-axis bearing rail. That's what we're trying to achieve. Now we're trying to achieve that parallel beam to this bearing rail in not only the plan view, which is what we see here, but also in the horizontal view as well. So this beam has got to run true in both axes to this bearing rail. Okay, that's what we're trying to achieve. Now let's just take a look here at mirror number 1. Now it's coming off of mirror number 1, and for it to run along parallel with this axis here and hit the centre of the second mirror, the mirror has got to be in the same relative position to the y-axis bearing rail as mirror number 1. In other words, I can't afford to have this mirror here out of line mechanically, because if it's out of line mechanically, when I try and point the beam to the centre of this mirror, it's not going to be parallel with this axis. So I shall never be able to achieve the goal that we're looking for, which is parallelism between the beam and this axis. So the very first thing that we're going to have to do, because this is like the foundation of the whole beam setup, we must make sure that mirror number 2 and mirror number 1 are mechanically in line with this y-axis. If they're not, we've got to fix it. We can't afford to have these out by more than 1mm, because otherwise, if we stick with our plus or minus 2mm, we should be touching the edge of the mirror. This is going to be an interesting problem, and it's going to test your engineering ingenuity, because there are very few things on the machine that are what I call good enough to use as a reference. I thought we might be able to use the machine case here. This is the green machine case as a reference, But when I put a straight edge along this surface here, it's probably out by a mil and a half. My original plan was that what I was going to do was to use this as case plane as a reference, measure from there to the rail, there to the rail, and then from that same reference to the centre of that mirror, and that reference to the centre of that mirror. And with a little bit of maths, we would have been able to work out what the difference between these two lines was. Not possible. So we're going to have to think of some other method. What I'm going to do to make more room for myself is to take the mirrors actually off of the block, because the mounting block is the more important thing that I'm interested in at the moment. If the mounting block is right, then I can use that as a reference to set my mirrors up. I'm no longer frightened of taking mirrors off and messing things up. There was a time when I first had this machine, it was one of the most fearful things that I dreaded. If I messed my mirrors up, would I ever get them back into line? What I'd like to do to start with is to actually check that this mirror plane here is actually sitting at 45 degrees to the basic squareness of the machine. Now, we've got to make some fairly sweeping assumptions, I suppose, about the way that this machine is made. The machine is obviously made with jigs. All this lot's welded together, it's all punched, formed and welded together on some sort of jigs. So we have to assume a certain degree of squareness and trueness about this frame. What I'm actually checking at the moment, whether this block is sitting here at 45 degrees relative to the back face of this enclosure. And the answer to that question is yes. So that's a pretty good start, the fact that we've got the block at the correct angle. Now this mirror block is exactly the same as the mirror block at the back. The other thing that's interesting is, after 2 weeks, well, after nearly 3 weeks now, there's my copper mirrors. Do they look tarnished? No. So you just wind these screws back out of the way. Now it's going to be a little bit more difficult to measure the 45 degree angle on this block. I've either got to measure it against this rail, and to be honest, I do know that there is a very high degree of squareness between this rail and that rail, so probably I'd better to use this as a measure of my 45 degree squareness than anything else. Now I know it doesn't sound like a piece of engineering measuring equipment, but this Perspex block has been machined and polished, so I know that it is very good, true and square. So what I can do is to use this as a reference off the front surface there and slide my 45 degree against it, and I can see that it's probably maybe 1 degree out. It needs twisting slightly. Now it may well be not only that it needs twisting, but it may need repositioning. So that's the next issue. How are we going to check for the centre? Well, I don't think we are going to be able to check for the centre, but what we can do, well, as far as I can see, the block at the back is 45.09 wide, and this block here is 44.91. So if we said they were 45 millimeters wide, those blocks, that's going to be probably good enough. But I really have got to have this set at the correct angle before I can use, what I want to use is one of these edges here, or both the edges, to set myself up a reference. So we need to loosen the screw off underneath there. As far as I can see, as I slide that onto there, that's perfect. So the angle is now correct at 45 degrees, but we don't know about the position of the centre of the mirror. So now what we're going to have to do is be a bit inventive about how we achieve that. Well, here's my solution. I've got some VHB, some very high bond strength tape. Right, there we go. There's a piece of tape on there. And I'll do the same on the rear block. Now, not everybody will have this in their workshop, but I just happen to have a piece of stainless steel square tube here, which is around about 15mm square, and it's just perfect for doing what I want to do. I'm going to poke it through the hole that goes to the back of the machine there. Now ideally what I want to do is to pick up on that vertical edge there and sit my piece of tube in line with that vertical edge, which is what I've just done there. I'll just stick it down so that it doesn't move, and I'll do the same on the back mirror. Okay, so now I've got myself a straight line through the corners of these two blocks. Now if I shift it across by the same amount, it will eventually get to the centre of the mirrors. So basically what I'm doing is checking the centre line of the mirrors, or these blocks, and now I should be able to reference between here and here and here and here. Let's go back to my big block of acrylic, because that looks like a very useful size. I can stand it on that rail. If I put those two together there, that should make a flat surface, which it does. So I can now move that to the back and see how that compares with what I find right at the back there. Now I can tell you now, before I look, there's about 1.5 mil difference in the height. It's not quite as important in the up and down direction, because remember, we've got 20mm to play with. We've probably got at least plus or minus 4 or 5mm from centre before we start having a serious impact on our beam collision with the edge of the mirror. Well, as I mentioned before we started, we're going to have to be a little bit ingenious about how we establish whether or not we've got a reasonable dimension here, because there's nothing to work with. So what I'm going to do here, I'm going to use the top of this rail as a flat reference, and I'm going to sit my block here on top of that rail and slide it across very gently till it just touches the rail. And at that point there, what I'm going to do is to measure the step difference to the rail, which is 3mm. Now we're going to come to the front and try and do exactly the same thing. Hold it square on the top of the rail there and slide it across till it just touches, and that's 2.99 as opposed to 3.08. So I think near as damn it those mirrors are in line, which is very important. So let me very carefully tighten these screws up. I only just crack them very gently. I'll do those up nice and tight, because we don't ever want to have to fiddle with that block again. This is a once-off setting. Now it might be crude, but even if it's 1 mil out, it's better than it being 2 or 3mm out and you never being able to get your alignment correct. This is not proper engineering, as you'll understand, but I haven't got a metrology lab to back me up, so we have to go to garage technology. So the only error that we found in these blocks basically is this one is 1 millimetre higher than the one at the back. Not a problem. Okay, well, we've now built our solid foundation upon which we can start our beam alignment. It was important that we had these mirrors set at 45 degrees, and it was important that a line joining the centre of this mirror and the centre of this mirror was basically parallel in both the vertical and the horizontal axis with this bearing rail. Okay, we now fix the block back on, and now comes the next vital trick. What we're going to do is to put a little bit of movement on this block, and then I'm going to put that in there, and I'm going to undo the back one until it just nips, like that. Now I'll just tighten it up until I can just get my piece of wire out, which is 1.5 millimeters wide, and then I'll do the same at the front here. I'll nip it in the front here, undo the screw until I nip it in there, tighten it up till it just comes out. There we go, and then I'll do the same for the top. Now in doing that, what I've actually done is set that block up absolutely parallel to this block. So technically that mirror is now sitting at 45 degrees, the same as the block. We're going to do the same to the front mirror now. And there we go. So that's the preliminary settings done. And you'll notice we've not even turned the machine on yet. Now I know that these blocks are correct because when I was having problems before, I managed to draw these blocks up and I checked the geometry of these blocks, so I know that the centre of the mirror is where I expect it to be, in the centre of the hole. So if we aim the laser for the centre of the hole, then I know that we've got it set up approximately on the mirror centre as well, give or take half a millimetre or so, I suspect. When I made the holes to fix my clamps down, I made them into slots. Although I've got this set to a nominal position, I think I might need more than the 3 millimeters that I've got on here to find the correct position in the middle there. So what I should do is loosen the screws off to start with to get a nominal starting position. Well, I've just slackened off the nuts now so that my tube, the base plate for my tube, is actually able to float around. And for the first time we're going to have a quick check to see where the beam is. Now, many of you will be asking the question, why am I not using my little red dot pointer? Well, the answer is quite simple. From experience, the Mark II and the Mark III, they were pretty good on a from scratch setup, but many people won't have the pointer. So what I'm using here is the standard technique, which I actually still find, much to my horror, is actually the easiest and best technique to use. Now what we're going to do is turn the power right down on this tube to about 10%. See what's happening as I press the pulse button. No, that's good. Now I'll just do a little pulse test, and I'm not far off centre. So I will just pull this across very, very slightly at the front here. Because basically whatever I pull across here will appear there, but it's completely different at the other end. We'll sort that out in a minute and I'll show you what I mean. So we'll just do a pulse test here. Slightly overcooked it. Just push it back a shade. And I would say that that looks pretty good for centre. We can check it again. And the great thing about this is you can sort of, it's semi-opaque, you can see where I'm aiming. So let's try that one more time. Yeah, that looks pretty good. This is the back of the enclosure. And what we've now got to do is to make sure that we set the tube parallel with the back face of the enclosure. So what we're going to do is make sure we're going to measure, or we're going to put packers, which is the easiest thing to do, put packing pieces down the back of the tube to make sure that it's the same distance away there and there. So then we can know that we've got the tube pointing 45 degrees, near enough, at our mirror, which is 45 degrees. And if we get that bit right, then nearly we should be in the middle of that mirror. We won't be quite, but I guess we won't be far out. But let's give it a try. Now I've got a whole box here of random packing pieces from my tests. 10mm, 4mm, 15mm, and there's a piece of 12mm. And then another piece of 12mm. So that is a perfect fit there, 2 pink pieces. So we now come to the other clamp and we'll see what we've got here. No, look, we can't get 2 pink pieces down there. So what we'll do, we'll slide this across until we can get 2 pink pieces down there, just like that. There we go. So now we know the tube is set up nice and parallel. Right, now that we know we've got the beam parallel to the back face of the machine, we'll do a quick test. And I think as near as makes no difference, we regard that as being central up and down, but we haven't set up and down yet. And it's certainly central left to right, which is great news. Now we've got a piece of 15mm there, and look at that, a piece of 4mm ply fits perfectly underneath there. Put another piece of this 15mm acrylic under here. So we shall need to undo the clamp and lift it up, and we'll lock it up in that position at the moment. So that's the next stage done, which is setting the beam up parallel in 2 planes before it gets even to the first mirror. We'll have just one more quick pulse test. There we go. We're happy with that. So that's stage 1 sorted. I've still got my packing pieces behind and underneath the tube because we should be coming back to this area later on in the procedure, but at the moment we've built a good foundation from which we can now start aligning the beam.